What's up, guys? How's it going? In this video, I'm going to go through this Leetcode problem number of matching subs. So this question was asked by Google for 18 times for the past 6 months. And let's take a look at this part. So given a string S, an array of strings, words, return a number of words of index I, that is a subsequent of the string S. A sequence of a string is a new string generated from the original string with some characters which can be none, deleted without changing the relative order of the remaining characters. So for example, ACE is a subsequence of A, B, C, D, E. So the question is a bit wordy, but essentially what it means is we have to maintain the relative order for from the given string. So for example, this is the master string, and a substring will be A, C, and E, which comes from here A, C, and E. So basically, they're still maintaining the relative order. Let's take a look at a few more example. And A is by itself is a substring of a subsequence of this string, and BB, which is not a subsequent of the original string, because as we can see only one character in here, B, and that's about it. A, C, and D, so it comes from A, C, and D. So this is another subsequent, and A, C, and E, which is also qualified because A, C, and E, which again follows the relative order. So for these guys over here, DSAHJPJAUF, and this one, let's see if that is a subsequence. So AH, so you can see AHJPJAU. So this is qualified. So this is the first one. JA, which is self, is also a subsequent because JA over here. So AHBWZ, GQ, and we do not see the relative order in the string. And T, well, we stopped right here, right? So T cannot be found anywhere in the string. So when I first approached this problem, the method come across my mind was the DFS, which I used at the beginning, but that didn't pass all the test cases because I got timeout. So the reason it was not efficient, but I think that's still a example that to go through because I got a chance to go through the DFS approach. So the method goes first, I have a dictionary that marks down all the positions of the character of the original string. So for example, D has a position of 0, and S has a position 1, A has a position of 2, etc. Actually, A has 2 positions. One is over here, another one is over here. So I use a set to collect all the positions. Okay, so that's a dictionary. That's the first step. And once again, that method actually works, but just not efficient enough. And then next step was I scanned through the words in the words list. For example, A, H, and then I find the relative position in the string in the dictionary that I talked about. So in this case, it will be 2. And then the next one will be H, which is over here. So I basically comparing the relative position that I got from the dictionary, right? So in this case, it's A, which is 0, 1, 2, which is 2, and H was, let me zoom in a little bit. H was 3, and J, so it's 4. So you get the idea, right? So basically, I scan through all the possible letters I can find on the words on the original string, and then to compare the index to see if one is greater than the other one. And then if it is, that means I am maintaining, so this word is maintaining the relative position that was created by the original string. And for example, in the last word in here, and T, I cannot even find anywhere. So it's automatically is not qualified. Okay, so that's the idea by using a DFS. So the reason why it's not very efficient was that I have to scan through the entire string, right? In the worst case scenario, for all the words, I have to scan through the entire string. So in the case where if the string is really, really long, and that's gonna be not efficient. Okay. In the second approach, I'm gonna show you, we only need to scan through the string once, and that can get us the answer. So that's much faster. So let's go through the first approach, which is not efficient enough, but I still think that's a good learning opportunity. So first thing is I have the post, which is a dictionary that collects all the position of the characters. So for all the index and the character in the string, and the key being the character, and so this is a default deck on the set, and I collect all the index. Let me show you the dictionary. Actually, I think it's more visual. Let's go print on the post. Okay, let's run that. As you can see, for this string A, B, C, D, E, and A has a position of 0, and B has a position of 1, etc. And if we have A and two A's, and that will collect all the positions for correspond to the letter A. Okay, so that's the first step, and we don't need that anymore. And then we have a DFS function that I will go through later on. So for all the word in the words set, if the letter is not in the position dictionary that we saw earlier, and then we are done. So we go through the next word. So essentially, that's this case. Okay, so first letter is not in the string, and then we are done. So we go to the next word. So else for each of the positions. So each of the possible positions in the original string, that comes from the original dictionary, the position dictionary, and then we do a DFS on it. So what do we pass on was the position index, also the rest of the word. Okay, and then we pass on the DFS dictionary, DFS function. So if the substring that we are given, so the first substring is everything but the first character, right? If the substring that we're given is an empty string, so that will be as in this case. Okay, so we pass in and everything but the first character, so that will be an empty string. If there's already an empty string, we are done. Okay, so we add 1 to the result, and then we are done, and then return true, because this is a subsequence. Okay, so we are done. If it is not a empty string, so what we need to do, we just look at the next character, okay, which is the first character on the substring, and then we look to the dictionary to get the position. And for the next for all the possible positions in the position dictionary we got, look at that next character for all the possible next positions. If the next position which comes from the original string is later than the current position, what is we gonna do another call on the DFS on the next position, and the substring that is 1 character short. So look at the original string. We have the over here, And now what we pass on the next call was 1 character short. Also, the indexing that we're looking at is with the next position. If one of this return the true, and then we return the true. Because we keep trying all the possible next positions. If one of them works, and then we are done. So this can save a little bit of runtime. And then we keep calling it this recursive DFS function until a point where the substring is empty. The given substring is empty, and we are done. Otherwise, we are not done, right? Otherwise, it is not a subsequent of the original string. And at the end, just return the result. We just keep track of all the possible subsequences. Yeah, so this is a DFS approach. I actually really like this approach because this approach can solve most of the problems, but in this case, it's not efficient enough, as you can see. We're gonna get timeout and sub one. And for time, it's gonna be the number of strings. No, not the number of words times the length of the string. And in this case, when the length of the string is really, really long, and that's gonna be not efficient because we have to scan through the string many, many times. In the next approach, where we will scan through the original string only one time. That's much faster, and we will use a iterator. So for those of you who might need some refresher on iterator, and this is an example, right? I have a string A, B, C, and I throw the string into an iterator, which in Python is a function iter, and I call it myIt. Basically stands for my iterator. And by the name itself, we know that it works sort of like a for loop, and that actually comes in really handy for this problem, right? So when we call the next method on this iterator object, and then it will give us a character at the time. Okay, so for the first call, let me run the function again. You can see it. Okay, and for the first call, we get the first character of the string, which is A, and then the next call is gonna get B. The third call will be C, which is the last character of the string, and then we reach the end of it, right? And then we have a optional argument, which is I put a hash in here, meaning that if we reach to the end, to prevent that we get an error, it would return a hash by default. Okay, and let's look at it again. So A, B, and C, and then we reach to the end, and then hash, and then hash, and then we keep going if we still keep call this method. Okay, and this is how it works in this example. This comes again. This comes in really handy for this problem. Let's walk through it. So we first have a letter iter dictionary. So basically, as the name says, the key is the letter. The value is the iterator. So I call a Python default dictionary. So the default element is the set. Okay, and then for all the words in the word set or in the words list, and we create an iterator on it. So basically, the key being the first character of the word, and then the value. So basically, the value is set, and then we add the iterator to the set. And then the iterator, what is it? What it takes in? It will be the rest of the word. Okay, so that's why it's from 1 to the end. Okay, the index of 1 to the end, and then we pass it through so we basically create a iterator object, and then add it to the set. Unfortunately, I couldn't it's not very good. If I print it off in the left iters dictionary. Otherwise, I could have shown you better. Right? It's not good. Like it shows the memory that that has the object, which is not very good visualization. But you can still see it, right? So for the letter A, and then we have a set, and then within that set we have some iterator object. And then for the letter, also we have two objects. As you can see, the first is the first object. So basically this is the first object. I think this is probably the empty string, and this is the second object. So that's the from A, C, D. Okay, so that's the so the key. So that's for the key A, and the value the set. And we have the next one, which is a B, which comes from actually three objects, right? So A and ACD and ACE, right? So we can see three iterators, 1, 2, and 3. And then also we have a B, and then another iterator object. Basically we push another B, the second B, to the iterator. And for the first one, we have the empty string in the iterator, we have the CD in the iterator, so we have a CE in the iterator. So we have three different iterators, okay? And this is exactly that. We push in the rest of the word to the iterator, and then create an object, and then push into the set. So we don't need to print it off again. And for the letter in the original string, so which is this string, okay? And we look back to the letter iters dictionary, and then pop it off based on that letter that we're looking at. For example, the first letter will be A, second letter will be B. So we look at that letter, find out all the iterators. Remember, this is the Perl, right? So we have collections of iterators, which is a set. Okay, and then if this iterators is not empty, and then for each of the iterator in iterators, and then the next letter is we call the next on the iterator, on each of the iterator. If this is not empty, otherwise it will be a hash. And then we push the new iterator, not the new iterator, the current iterator we're looking at. However, this is not the same as the one in here because we call the next method to it already. And then the new one will be the next, then the new key will be the next letter. I think a better visualization would be example, but the word example looks like this. So let's say we have a string looks like this, DCAOG. Okay, and then now we create this letter iters dictionary, which looks like this. And the word that we are given is cat, cop, and dog. Okay, and this is where we create this letter iters dictionary, right? So for C, we got the iterator that contains actually in my example it's going to be the key being C, and the iterators that AT, that's AT, and also OP, and then OG, and then the key being D in here. And then now we iterate the string. So then the first character is D, and then we look at the dictionary. Do we see D in the dictionary? And we don't. Okay, and then now we look at the second character, which is C, and then we look at the dictionary of the key of C. Do we see C? And the answer is yes, because we see it right here, right? And then we truncate. So this is where we, this is why we, the iterator comes into handy, right? So we can call the next method, right? And the next one will be AT and OP, okay? And then O, you group to OP and OG that we had earlier. And now A and then C is gone because we call that next function. And now it's only, what is left is only T. Okay. And then the next one will be, the next character will be A, okay, which is over here. And now we look back to the dictionary and do the same thing again. okay, to see the key being A, and what do we have is A is T, right? So right here, and then that's about it. And then we don't have this one, the key is O, it's not matching. The last one is O, and that's exactly what we need for this guy over here, right? And then after we truncate the letter O, we got G and P, and it's exactly that. And then T right here, because we don't have any matching for T. The last one is G, okay? And do we have any G? And yes, we do. And so this is one word that is got finished. And we do not get finished for this one, not for this one. And that's it. So again, so the beauty of this is we only have to scan through the string once. And this is why it's much more efficient than the first method. And each time when we iterate each of the words, we call the next function on the iterator, right? So again, for all the iterators, for each one of the iterator, we call the next function. And if we are not reaching the end, we just call the next character. If we reach the end, we will return the hash, and then the next letter, either the next letter or the hash, will be pushed through the iterator. And at the end, we just measure on the letter iter's dictionary on the hash, where it indicates that we reach to the end of the word. Okay, let's run that. Yeah, as you can see, it's pretty efficient. So for Tom, and first we will iterate all the words. So this is gonna be big O of number of words, and then it's gonna be big O of number of letters times the number of all the possible iterators, the number of all the possible iterators. So this is so much for this solution. I hope this is helpful. If it is, please consider like and subscribe. That would be huge support. Thank you so much for watching. I will see you in the next video. Thank you.